Okay, let's discuss measure of dispersion. That's for quantitative data, definitely. What is the measure of dispersion? We want to measure the degree of data dispersion in numerical values. There are several measures. Variance or standard deviation is used a lot, and there are also range and interquartile ranges. What is variance? Suppose you have 4 data. 3, 4, 6, 7, therefore mean is located here. We want to calculate distance from data to mean. From x1 is 3, 3 minus 5 is negative 2. Since it has a negative number, we'd like to have some positive number to check the variation. Therefore, well, we squared them. Same thing here, the distance is negative 1. From 4 minus 5 is negative 1, square them. And then here, 6 minus 5 is 1, square them. 7 minus 5, that's 2, square them. Add it whole, divide by number of data, that's 4. It is roughly average of squared deviation, squared distance. That's the meaning of variance. It is not easy to interpret directly, but consider it is average of squared distance. Well, that means if data located around the mean, well, the measure of the variance will have a small value. If data is widely spread, then we would have a larger variance. That's the only thing we can say. Well, somehow, if you have a population data, you have to apply this formula. Okay, N is the number of population data. Mu, as you know, is a population mean. In case of sample data, somehow you have to calculate the squared distance. You remember xy is the notation for sample mean, and then divide by n minus 1. There is important reason why we are dividing by n minus 1 in case of sample, but let's postpone that discussion until chapter 6. Okay? We'll discuss in detail. There is important reason. There is another measure which is related with variance is standard deviation. It is nothing but just the square root of variance. Do you remember the variance is the average squared distance? Therefore, it is hard to interpret. In case the standard deviation, you take a square root of them. Therefore, unit is the same thing as data. Roughly, you can say this. Suppose the average height of a male student is 170 centimeter, and their standard deviation is 5 centimeter. What does it mean? Just consider that mean plus minus 1 standard deviation. In the case, from 170 plus minus 1 standard deviation gives you interval 165 to 175. There would be many numbers. You will see that in case of a normal distribution, well, there are roughly 70%, 68% of the data around that interval. That's the interpretation of standard deviation. Let's try to calculate mean and standard deviation. They say it is a sample data. It's to be given. Okay? You have 7 numbers. Calculation of mean, we denote it as x bar. Added whole divided by 7 will give you this number. What is squared distance? the variance we denote it as square. From each number, subtract mean 5 minus 6 square, 6 minus 6 square, 3 minus 6 square, 7 minus 6 square, keep going on, 9 minus 6, 4 minus 6 square, 8 minus 6 square, add it whole, but be sure since we mentioned that this data is a sample, therefore, well, you have to divide by 7 minus 1. The variance is 4.6, the actual number is 4.667, and standard deviation is 2.16. Instead, calculate both population and sample standard deviation. There is a slight variation of standard deviation. They call it coefficient of variation. What does it mean? Well, it is nothing but divide standard deviation by mean and multiply 100. It is some kind of percent. Okay? Well, why they are calculating that? If they specify population data, you use this formula. If it is a sample data, you use this formula. Why they are doing that? Sometimes you need to compare two different set of data. Typical example would be your height data and your weight data. The unit is different. Height can be centimeter and weight can be kilogram. You cannot compare directly the standard deviation. If they have all same number, 5, it has different meaning. Therefore, they just calculate percent, okay, compare with their mean. Here's a simple example. Suppose you have weekly sales, okay, and their standard deviation, and then monthly sale data, and then their standard deviation. You cannot compare directly their standard deviation. Therefore, you calculate the percent coefficient of variation. It says weekly sale has 20% of variation compared with the mean. But in case of a monthly sale, it has 9%, 2%. That means it gives you idea. I mean, there are lots of fluctuation in the weekly sales, but not much compared with the weekly sale, not much variation about the monthly sale. It's a slightly different one, but it is useful to compare two set of data. Here's another measure of dispersion. Range is the simple one, it's just from the maximum subtract minimum. But range is simple, it's not a good measure because if there is extreme point, well, there's too much changes. Instead, they are using IQR, interquartile range. It's a variation of the range. In order to know that, you need P percentile. It is simply, suppose you have data. You arrange in order from the lowest to highest. Let's say if there are 100 data, approximately 20 percentile imply 20 data when you arrange it in order. Well, 25 percentile data imply the 25%. I mean, when you arrange the data in order, in case of 100 data, that's 25th data. There's some tip. We can calculate Q1 and Q3. P percentile, depending on data size, sometimes it is a little vague. But about the Q1, Q3, yeah, there is clear formula. What does it mean? Interquartile range is the range between Q3 minus Q1. What's the interpretation? Do you remember the trimmed mean? If there are extreme point, we remove sometimes maximum and minimum, take average. It's a similar concept. Range, well, it's not good measure because there are extreme point, too much variation. But it remove bottom 25% and top 25% calculate range. It is a stable measure. Therefore, it is used a lot. Let's calculate one example. Suppose you have only this data. Well, how can you find the range and interquartile range? Range is so simple. From maximum, subtract minimum, it will give you 6. To calculate interquartile range, you first arrange in ascending order like this. Median, as you learned already, is here, is center point. We have 5 data, therefore, well, third, that's 5 plus 1 divided by 2 is third located data, that's 6. How can you calculate the interquartile range? Divide this sorted data into 2 parts. Since we have only 5 data, well, we cannot clearly cut into 2 parts. If you have odd number, just add median to here. Then you have 6 numbers, 3, 5, 6, 6, 7, 9. Then you can split into 2 pieces like this. Okay? That's easy way. After you divide it into 2 pieces, calculate the median of this number, that is 5, that's Q1. Calculate the median of this number is Q3. Okay? IQR, therefore, is Q3 minus Q1 is 2. That's the easiest way. Suppose you have even number, what are you gonna do? Then sorted it, you calculate the median, but you don't need to put median here again because in case of even number, you can split it naturally. Okay? Then calculate median of first part, that's Q1. Calculate median of second part, that's Q3. In order to utilize these things, IQR things, we plot this kind of box plot. Here's an idea to plot box things. Full name is box whisker, but we simply call box plot. First, you calculate Q1, Q3. Okay. After you calculate Q1 and Q3, just mark it here. You can just draw a box, rectangle which connect Q1 and Q3. It's the main body. We are thinking this is the upper 25%, it's the bottom 25%. These are the IQR, right? Q3 minus Q1. That's the important body, the box. Then you may plot the median here. Then draw dotted line from Q3 plus 1.5 IQR. I mean, from here, you already calculated this distance, multiply by 1.5. Okay, find this location. Then mark it dotted line. If there is some data like this, we consider it is extreme point. Then why don't you temporarily remove this extreme point from consideration? Then calculate, using the remaining data, calculate the minimum and maximum and connect it. This is what we call box plot. Well, this is a general idea, but some package like Easter, well, they don't plot this dotted line. They only calculate the minimum, maximum, and connect it. Well, there are many variations of box plot. Well, we expect this kind of plot. Let's practice. Do you have estat with you? Type estat.me in URL, then click EX button, and then click ebook. We are in chapter 4. Let's consider teacher's age. Suppose you have this continuous data. Then if you want to draw something, maybe dot plot would be appropriate. But now you are ready to use this box plot also. You may plot the horizontal way or vertical way. It's up to you. You can calculate a descriptive measure related with this box plot. You have mean, variance, and means is population variance. If data is population, you choose whatever you like. Okay, so n-1 is sample standard deviation, a sample variance, and there is corresponding standard deviation, minimum, first quartile, median, third quartile, maximum range, interquartile range, coefficient of variation. Suppose there is a group variable like this, okay? I mean, teachers can be divided into male and female. Then you click this one. Click means selecting group variable. Click this one. They're gonna plot, box plot to compare two population easily. What's the idea? I mean, this is the main body. It looks like a male teacher. This is female teacher. You can see that there are much dispersion than male teachers. Okay? We compare the IQR, the length. Maybe that's a good tip. I mean, after removing top 25% each, we compare them. It's a good idea. Why don't you use it from next time?